This is a several part video about the remote relay circuit that uses the Cat5 jack that I talked about in another video. This is a sample of how to use the circuit, and it's also a good demonstration of how you can power high current electronics with this or a similar device, like some of the wireless switches that you can buy now. This one is opposite of that. It's not wireless. It requires a hardwire connection, which comes from the central location, which I explained that in another video. And in that video I also talked about how I wouldn't hook it up to some high current situations like your heater or anything, but this that I'm about to show you will give you an idea how you can make it work on your heater safely with no issues. And in another video I showed how to install a mod plug for Cat5. If you know how, that's great. It uses a standard pinout. Again, this is not a network device. Do not hook this up to your switch or router. It's not for that. Like I said, I thought I'd just go ahead and do a video to demonstrate how to do this mod plug, as well as punch down a data jack. So I don't know, maybe it'll come in handy for some other people, because I've seen some pretty horrible connections. Now if you watch the other video, you'll know how I hooked everything up in my little system, and you'd know that I only used the brown and the orange. So these you don't need. But if you're running one of these, you could also use these as sensor wires. You could break them away from the connection and use them for sensor wires to run back to the processor, whether that's a thermistor for a thermostat or whatever. That's basically what I use, as a thermistor from a condensing unit, and it works really well. Alright, so this end is going to hook up in the box like I showed. The pinout is orange and white. It's 12 volt DC positive. The orange is 12 volt negative. The brown is 5 volt positive. No, sorry, the brown and white is 5 volt positive, and the brown is 5 volt negative. And our other end is as such. Alright, so just want to snap her in there like that. I was trying to avoid this. I also might mention that since I'm only using 2 of the pairs here, you could also run 2 of these relays on one cable. You just have to break your wire out, which the twisting of the pairs wouldn't necessarily apply. It might be a good idea to go ahead and keep them as twisted as far as you can, but it's not as important for this application. Alright, we're all hooked up on the other side, connected here. Now it's time to talk about what we're doing. First, let me put my tools up and get this stuff out of the way. Alright, so what we have is the relay circuit. We have 120 volts coming into here. The hot goes into the relay, comes out of the relay, the neutral wire. So then they run into this transformer, which has a 3.2 amp circuit breaker on there. And what that does is, once this kicks on, it allows the transformer to run, and then it turns on what this is a contactor, and it's just wired up via 24 volt. I believe this is a 75 volt amp transformer. This is what you typically find in your heating and air unit, probably in your air handler. This particular transformer will run at 120 volts, 208 volts, 240 volts, or 480 volts, which is what all these extra wires are. We're only using 120 volts, and we are going to 24 volts. Now, the contactor, we got our common wire coming to this terminal. You can see it connects right through, and your hot lead is over here on the switch side. Now what this does is puts out 24 volts into a coil that's down here, which pulls this in and allows the power to run through to light up this bulb here. Alright, and to turn it on, we're going to use this. Right now I've just switched it over to use this one from the fans. Use this when in the wintertime me and my 3 sons get together and play Xbox. So there's 4 Xboxes going and 4 TVs. So we added some PC fans in a little array and controlled them off of this, as well as some ambient lights that sit over the TVs. Well, it's not winter now, so we're not using them. So right now I'm using the fans switch. Now, this is in a lot of people's furnace in their home, or whatever they have, they've got a transformer that's running all the time. Now what I do is I use my thermostat circuit, which then flips on my relay, which kicks on this transformer. That way this transformer is not running all the time. It's only pulling power when my relay says so. So if you was to run like this, and you're controlling something that can be run off a contactor, and something that's okay and safe to run off a contactor, then you can run high current devices off of devices like these and other ones that you can get online that are wireless, whether they're from China or made in the US, whatever. You can use them for a high current situation. But also in doing it this way, you save energy without this running all the time. Granted, it's only a 75 volt amp, but still, it runs all the time. And think about the seasons that you're not using your heat for, say, a month, 2 months, or other people out there who don't use them for longer than that. It's possible that your transformer is just running all the time and you don't even need it. It just depends on the age of your system and basically how smart the board is. And you may notice I'm not using the grounds for this little example. And these 2 cords are running to the same power source, which is a power strip to the right of me here. And they are both on the same bank, which is on the surge protection side. And this transformer is especially cool because it's got the 3.2 amp breaker right here. So if anything goes wrong with that coil, this is going to trip and it's going to throw that breaker there. So it gives a little safety feature. Alright, again, just another little rundown. The brown pair is from a 5 volt source, whether that's a microcontroller or even just 5 volts on a switch, either one. And the orange pair is 12 volt. That's what drives the relay. You could probably use it in custom ways if you needed to, as long as I think you're getting 12 volt on the relay. I think it's 12 volt only. Alright, so here's just a sample of hooking this up and using it in a live situation. And this is just going to represent maybe a high voltage device, more of a high current device. It's just a simulation here. So once I kick on the fan light here, I'll turn on, and nothing. I had a problem with this before, I think. Oh, you know what? I didn't turn on my power strip, so let me just turn that back off. Okay, that's back off. Alright, here now the power strip's on. Okay. And this is also, in the other video I showed the other microcontroller circuit. This is just tells me that the air is off. If I ever log into it, it shows the temperature outside. But the temperature is actually not hooked up. It's on, as I said in the other video, I moved it over to another one, so actually there's no thermistor on that. So that's why it's not even reading right. That's obviously not the temperature outside. Obvious for me, anyway. Alright, so here we go. I'm going to turn her on. And it's right on. Now let's turn it back off here. Like again, this is good for, I mean, even a lower current situation. Just depends on what you're needing it for. Like I said, for those that don't know, there's a coil inside there that pulls down this latch. Now for 220 volt, which said this would work just fine for 220 volts even, if you were running a heater. This is the exact setup basically I have, and I'm running 240 volts off of those two, but I'm using a dual contactor. And if you're using that high voltage, or 120 volts on each line, then I would definitely go with the dual contact. But if you're just doing 120 volts, this is fine. Just a contact on the hot, neutral's fine, and just like that. I'll show you again here. Alright, let me show you. Also on the other side. Alright, here's the panel I showed in the other video. I'm just going to show over here again. Like I said, from here down is the 12 volt, and they're all tied together. I just have to move these jumper pins over for which one I want to activate, basically. So there's 12 volt going out, and these show what's on, and nothing's on right now. So once I hit fan on for the circuit over there, you can see it now. This pin's on, and it only lights up when a certain pin is, because like I said in the other video, I cut out the traces there to individualize these fuses. So all the 5 volts are fused, and all the 12 volts are fused as well. Sometimes it takes a moment to refresh. I have authentication on here, and I have an app that I made on my phone as well that logs straight into it. Alright, thanks for watching, and I hope you enjoyed.